Alright, in this tutorial we're going to talk about linked lists, which are just another way that we can hold information. The nice thing about linked lists is that they're dynamic, meaning that they grow and shrink as necessary. Therefore, they're always going to be a perfect fit in memory. We're only going to allocate memory when we need to add new data, but it's going to require us to have a little bit more code. Now, one of the issues with linked lists is that we have slow access to data, and this is relative to arrays, because with arrays we could access a particular slot using an index, and we can't do that with linked lists. We'll talk about that a little bit later. Alright, to begin our discussion, we have to talk about a node. And on the inside of a node, you're going to have a piece or a set of data. For example, it could be something as small as an int, or it could be something complex like an object. So for this example, we'll just stick with ints, and you can see that we have one node at the head of the list, and its value is 75. Nodes also have a reference or a pointer to the next thing in the list, and a lot of times we'll refer to that as next. Now note, in this case, the way this pointer looks, that means that next is pointing to null, meaning that this is the end of the list. If we were going to code this up, it might look something like this. We would have class node, we'd have a piece of data, and then we'd have a reference to the next node. Now if you look closely, you'll see that one of our variables is of the same data type as the class that we're defining. So you may think that this is recursive, and that's not really what's going on. It's not like we have a node on the inside of a node on the inside of a node. Instead, we're going to make a chain of these nodes, and hence the name linked list. So we have a couple of different ways that we can add to this list. We can add to the end of the list, and here you can see I've added a 21 and a 99. Note that the data isn't necessarily sorted, and we'll talk about that a little bit later. We could also add it to the beginning, but we have to be careful with our pointers here. So let's say that I wanted to add the value 13. What I could do is I could create a temporary node, and here you can see it down here on the bottom. And then I could have temp's next pointer point to what head is pointing to. And then after that I could adjust the head pointer to point to the same thing that temp is pointing to. So in this case you can see that the head is pointing to 13 and the 13 is pointing to the 75. So if we were to rearrange this, you can see that we successfully added 13 to the beginning of the list. Another way that we could add nodes is to the middle of the list. And this is commonly the way that you would maintain a sorted list. So say for example we wanted to add the value 80. You can see right now that it would go between the 75 and the 99. However, we don't have direct access to this pointer, so we're going to have to start with the head pointer. Because the head pointer isn't null right now, I can compare the 21 that it's pointing to with the value 80. Now if the value that I was adding was less than 21, I would simply add that value to the beginning of the list. However, 80 isn't less than 21, so I want to look at the next pointer. So again, I'm looking at head's next pointer, and then I'm going to compare the value 80 with 75. So because 80 isn't less than 75, I have to move on to the next node. Now in this case we're going to do another comparison, and we're going to find out that 80 is less than 99, so we now know where in the list we need to put this 80. So really similar to what we did before, we're going to create a temporary node for the 80, and then we're going to adjust the pointers. So in this case we're going to have temp's next pointer point to the same thing that 75's next pointer is pointing to, which is the 99. And then we'll have 75's next pointer point to the same thing that temp is pointing to. So in doing so, you can see that we could follow this list and it maintains the order. Now we have to be a little bit careful in how we adjust these pointers. If instead we had had the 75's next pointer point to temp first, then you can see that nobody's really pointing to that 99. And then we were to try to update temp's next pointer to point to the same thing that 75's next pointer points to, you'd see we'd have a problem. Essentially, this last node is referring to itself, so technically there's no end to this list. Another problem is that nobody's pointing to this 99, so therefore we've lost the rest of our list. And when we talk about objects that are no longer pointed to, we refer to them as garbage. In fact, there's a thing called a garbage collector in languages like C# and Java that'll go and find all of these pieces of garbage and then return them back to the operating system. Now you may be asking, why does this happen? Well, remember we only have access to one variable, and that's the head variable. It's not like we can bounce around this list and have direct access to each one of these nodes. We have to traverse this list from the beginning, meaning the head variable, and follow all of these next pointers through the entire list. So you can see because no variable points to this 99, there's no way that we can get to it. Now there's one other thing that I'd like to note. In all of these examples, we've had our nodes laid out nicely on the screen. And because of that, you might think that they're actually next to each other in memory. Well, what's really going on is when we allocate a new node for this list, you don't know where that node's going to be in memory. So if we were to really traverse this list, we would start at the head, go to the 21, and that may take us into a totally different place in memory. And if we were to continue following this list, you could see that we would jump around quite a bit. So that's the overview of linked lists. The main thing that you should remember is that linked lists are dynamic, meaning that they grow and shrink as necessary. And because they do that, they're always going to be a perfect fit in memory. We also have a couple different ways that we can insert to a linked list. We can do it at the beginning, the end, or the middle in the case of sorted lists. And also remember that the order that we adjust the pointers is going to be really important. You don't want to lose the data in your list. And even though linked lists are dynamic, they're slow. And when we say slow, it's with regard to the access to the information. Unlike arrays, we can't just jump to the spot that we want to go to. We actually have to traverse the entire linked list. So that's it for now. Let's go ahead and get coding.